This question is called Cars on the Road. It says if the probability of observing at least one car on a highway during any 20-minute time interval is 609 over 625, then what is the probability of observing at least one car during any 5-minute time interval? Assume that the probability of seeing a car at any moment is uniform or constant for the entire 20 minutes. When I first saw this question, my first thought was like a naive approach. It was saying, oh, if it's some probability for 20 minutes, then for a fourth of that time, it should be a fourth of the probability. But that's not how it works. Because if you imagine, right, coins, if you say the probability of seeing heads in 4 coin flips is 15 out of 16, right? The only case where you wouldn't see heads is if you got all tails, which is 1/16. The probability of seeing heads in 1 coin flip with the same approach would be naively that divided by 4. But we are seeing it in 1 flip, that divided by 4, but that's not true, right? The probability of seeing that in 1 flip is 1/2. So we have to find a different approach to this. So if we have the time interval, right, this is the whole 20 minutes, and we're saying the probability of seeing a car at any 5-minute interval. So let's create 5-minute time intervals. Let's create one here, 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 right? These are all 5 minutes, right? Let's say the probability of seeing a car in 5 minutes is P. That's our answer. We're trying to solve for car during 5 min. Okay. That means the probability of not seeing a car during those 5 minutes is 1 minus P, right? So for us to not see a car in this time span is 1 minus P. For us to not see a car in this time span is 1 minus P, and this one's 1 minus P, and this one's minus P. Okay, the probability of not seeing a car in this whole time span, we know is, right, if you look at this, that's probably of seeing a car in that time span. So not seeing a car is 1 minus 609 over 625, which is 16 over 625. So that's probability of not seeing a car in the 20-minute time span. Well, if you consider this question, you can see that these are all equal. Probability of not seeing a car in any of those 5 minutes is the same as not seeing a car in the whole 20 minutes. And so you can say probability of not seeing a car in here, 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 and here is equal to this. Okay. So how do we set that up? We're going to say it's 1 minus P to the power of 4 equals 16 over 625. Now, how are we able to just multiply the 1 minus P's together? Because each seeing car in each of these 5-minute time spans is independent. And so we can use simply multiplication to show the and property. The and, what was it called? The and, whatever. Like the and is, you can use multiplication for it if they're independent. Okay, so we're going to say 1 minus P to the power of 4 equals 16 over 625. And so take the 4th root. 1 minus P equals 2 over 5. And so P equals 3/5. And that's the final answer. So again, we broke it up into 4 portions. Not seeing a car in any one of those 4 portions is 1 minus P. Not seeing it in all 4 portions is 1 minus P to the power of 4, which is the same as not seeing a car in the whole 20 minutes, which we had the number for that here. And 1 minus that was this. Make them equal to each other, and you can get the answer by solving for P. And that's the answer. That's all.